Greetings, Alpha Squad. Um, After the mocks, I thought it might be best to save a bit of classroom time by going through some of these questions on the video. I'm only going to go through the ones that we've done ourselves or the ones that you guys covered last year. I'm not obviously going to go through any of the questions on the new material yet, just because there'll be no real point. And you have to forgive me, I'm a bit rusty at this. It's been a while, so let's crack on. Okay, so to measure the acceleration, you need to measure the initial velocity, wait a few seconds, t, and then measure it again. And then use one of the Suvat equations to calculate the acceleration. V equals u plus at is the easiest here. You can also do it if you have the displacement between the two, and use one of the other Suvat ones, the v squared one. But I think v equals u plus at is the simplest way forward there. Okay, before we go on with this question, just a quick note on graphs in general in science. So in biology and chemistry and sometimes in physics, the convention tends to be to put the independent variable in whatever experiment you're looking at along the x-axis. So the independent is the variable that you're going to manipulate and change to see what happens. And the dependent variable, which is the thing that will change because of the independent variable, so the thing that you're going to observe, that usually goes on the y-axis. Now, sometimes though, it can be easier in physics if you're working with a particular equation to do it the other way around, because sometimes the slope will give you kind of what you're looking for, which is the case here. So this is a good example of that. So a pro tip here is whenever you get a question, just read through it first fully before kind of jumping in, because it can make your life a lot easier in the long run. So for example, here later on, they're going to be asking us to find the mass of the object. So they've given us the force and the acceleration that it causes, but we need to find the mass. So in this case, rearranging F equals ma, we have the mass is the force divided by the acceleration. So in terms of graphs, this is where the slope is probably the easiest way to do it. So slope is going to be the rise over run. How far does the graph go up versus how far does it go across? So here I think it's going to be best to put the force on the y-axis and acceleration going along the x-axis, because it will allow us to easily calculate the slope of our resultant graph. Okay, my computer skills are a little rusty here, so my graph doesn't have units on it, but obviously label your axes, whack on the units, make sure your graph is nice and big, and then do your line of best fit. Remember, your line of best fit doesn't have to go through all your results, but has to go as near to them as possible, and try to have as many above that line as you have below it. And finally, to get the mass, you just get the slope of that line. I'm going to cheat a little here and work it out. 1 second. Okay, so once you put in your line of best fit, just calculate the slope. So how far does it go up versus how far it goes across. And the idea should be about 1.7 kilos there, but anywhere between 1.5 and 2 is acceptable. Okay, and for the final bit, providing graph, student found the line did not go through the origin. Suggest a reason and describe how you could adjust the apparatus so it will go through the origin. Okay, well, there's always going to be a small bit of friction left. So even with an air track blower, there's going to be a tiny amount of friction either between the rider and the track, or just air resistance. So to kind of eliminate that, just change the elevation of the air track blower a little bit, or whatever apparatus you're using, just change the slope of it. Okay. Okay, second question is a nice little heat transfer one. I don't think there's any real surprises here, but let's have a look at it and work at it. Okay, so here's the setup. You've got your power supply, a voltmeter hooked up across the heating element, ammeter in series. You want a container for your water, copper calorimeter, wrapped in some insulation, thermometer poking at the top. I left out the lid just for clarity because I'm working on the whiteboard here. A stopwatch for timing it, and a mass balance for measuring the water that you used. And just label them. I didn't want to cluster up my diagram there, so there you go. Boom. So to find the total energy transfer to the immersion heater, just multiply the current times the voltage, which gives us 48 watts. So remember that's joules per second. So to find out the total energy transferred, you times 48 watts multiplied by the amount of time it was on for, which will give you your final answer in joules. Okay, they ask why is an initial temperature of 16 degrees Celsius chosen? Because it's going to gain some heat from the environment at the start, but that's balanced by the heat that will be lost to the second half of the experiment. So it's to balance energy coming in from the environment versus energy going out. Okay, these come back to haunt us. So starting off, the energy transferred is the mass times the heat capacity of whatever material you're talking about times the temperature change that it brought about. So rearranging that equals m times c times delta t. Rearrange that in terms of c because that's what we're trying to find out, the heat capacity. So that's the total energy transferred divided by the mass, and also divided by the temperature change. So 21,600 joules is given to us in the question, divided by a mass of 500 grams, which is 0.5 kilos, and temperature difference of 8 degrees gives me gives us, beg your pardon, 5,400 joules per kilogram per Kelvin. Okay, final part of this one is to figure out how long the immersion was on for. Well, we're told that 21,600 joules was transferred, and we know that it's going at a rate of 48 watts. So to find out the time, just divide 21,600 joules by 48 watts, and it gets you 450 seconds, or 7.5 minutes. Either or, you can even seconds, it's grand. I'm going to call a line under this for now. I'm just trying this as a trial run to see if these videos work. But I'll hopefully put more up with the rest of the mock on a little later on the holiday. Thanks, bye.